this lecture, we can study about the computation of r-1's complement. Previous lecture, we have studied about r's complement, where r denotes the base of a number system. Consider the decimal number system. R's complement is 10's complement. So what is r-1's complement? That is 9's complement. In the case of binary number system, r is equal to 2. Therefore, r's complement is 2's complement. So, r-1's complement is 1's complement. So, in decimal number system, 10's complement and 9's complement denotes r's complement and r-1's complement respectively. And in the case of binary number system, 2's complement and 1's complement denotes r's complement and r-1 complement respectively. And we have already seen that the equation used to compute r's complement is r raised to n minus capital N, where r is the base and small letter n is the number of integers and n is the original number. So let's see the equation to compute r-1's complement. So the equation is r raised to n minus r raised to minus m minus capital N, where n is the positive integer whose complement we are going to find out. M is the positive integer whose complement we are going to find out. Then r is the base or radix of the number system. Then n is the number of digits in the integer part. So suppose the number is 15.6 in the case of decimal number system. So the number of integers is 2 and the number of digits in the fractional part is 1. So n is 2 and m is equal to 1. So n is nothing but number of digits in integer part and m is the number of digits in fractional part. So r-1's complement is given by r raised to n minus r raised to minus m minus capital N. Let's see the computation of 9's complement in the case of decimal number system with base equal to 10. So the example, we are considering the number 52520 to the base 10. So n is equal to 52520 as given in the question. Then n, small letter n, is the number of integers or number of digits in the integer part. So 1, 2, 3, 4, 5. Small letter n is equal to 5. Small letter m is equal to 0. Since there are no digits in the fractional part, so m is equal to 0 and r is equal to 10 since it is a decimal number. So then we can calculate this 9's complement using the equation r raised to n minus r raised to minus m minus capital N. So r raised to n, r is 10, 10 raised to 5 minus 10 raised to minus 0. Minus 0 is not there, so 10 raised to 0 minus 52520, that is n. Then what is 10 raised to 5? Yes, 1 followed by 5 zeros minus 10 raised to 0 is nothing but 1. 10 raised to 0 is 1 minus 52520. When we evaluate this number, we will get the result as 47479 to the base 10. In this way, we can compute the 9's complement in the case of decimal number system. Next, we can see another example. Compute the 9's complement of 25.639 to the base 10. Again, n is equal to 25.39. Then, number of digits in the integer part, that is 2, 5. So, number of digits 2. Then, number of digits in the fractional part is 3, 6, 3, 9. So, m is equal to 3 and r is equal to 10. Substituting in the equation, we will get 10 square minus 10 raised to minus 3 minus 25.639. We can evaluate it using a calculator or manually and we will get the result as 74.360 to the base 10. So, the complement of 9's complement of 25.639 is equal to 74.360 to the base 10. Next, we will see another example for finding the 9's complement. That is, find 9's complement of 0.3267 to the base 10. So, n is 0.3267. Capital N is equal to 0 since there are no digits on the integer side, m is equal to 4. That is number of digits in the fractional part. 1, 2, 3, 4. M is equal to 4. Base or radix equal to 10. So we using the equation, we can write it as r raised to n minus r raised to minus m minus capital N. So r is 10. 10 raised to 0 minus 10 raised to minus 4 minus 0.3267. So 10 raised to 0 is 1 minus 10 raised to minus 4 is 1 by 10 raised to 4 minus 0.3267. You can evaluate it using calculator or manually just like this. 1 minus 0.001 minus 0.3267. So 1 minus 0.001 is equal to 0.9999 minus 0.3267. Evaluating these numbers or difference, we will get the answer as 0.6732 to the base 10. So the 9th complement of this number is 0.6732 to the base 10. Next, without using this equation, there is a shortcut method for finding the 9th complement. The trick is that we need to subtract every digit from 9. There is no difference in the logic depending upon the position, as we have seen in the case of 10th complement. In order to find 9th complement, we can simply subtract each digit from 9. So find the 9th complement of 25639 to the base 10. So it's a decimal number system. So 9th complement implies it is r minus 1 complement or 9th complement. To find it, we need to subtract the given digits from 9. So 9 minus 9, 0. 9 minus 3, 6. 9 minus 6, 3. So the fractional side is over. Then we need to subtract 9 minus 5. 9 minus 5 is 4. 9 minus 2 is 7. So the answer is 74360 to the base 10. 9th complement of this number is 74.360 to the base 10. Then using the norm equation, let's see how we can find out the 1's complement. Since the base is 2, 1's complement is r minus 1's complement, that is 2 minus 1, 1's complement of the given number. The number is given as 101100. So capital letter N is equal to 101100 and number of digit 2 plus 2 plus 2, that is 6. Then there are no integers on the or digits on the fractional side. Therefore, m is equal to 0, r equal to 2. Since the base is 2, r is equal to 2. Then 1's complement of 101100 to the base 2 is equal to 2 raised to 6 minus 2 raised to 0 minus 101100. That is, we are simply substituting in the equation r raised to n minus r raised to minus m minus capital N. But here we need to take care, this is not decimal subtraction, this is binary subtraction. 2 raised to 6. How to compute 2 raised to 6? We have to put a 1 on the position corresponding to 2 raised to 6. 2 raised to 0, 0. 2 raised to 1. 2 square, 2 cube, 2 raised to 4, 2 raised to 5, 2 raised to 6. That position we will put a 1 and all other bit position we will make it as 0. Then 2 raised to 0 is 1. So this number minus 1 minus 101100. So we need to perform this operation first. Then from that result we need to subtract this number. We can perform it using binary subtraction rules and you will get the result as 010011. But there is a shortcut method and easy method to find out the 1's complement. There is no need to evaluate this complex equation. 1's complement of a binary number can be found out by changing 1's to 0's and 0's to 1. Let's see an example. You can use this method to find out the 1's complement. Since we are using the binary numbers more frequently in this module, we need to find out 1's complement very often. So you can learn this quick method and make use of it. So 1's complement of 0.0110. The rule is that we have to change 0's to 1's and 1's to 0's. So the first 0 is changed to 1. Then 1 comes, that is changed to 0. Then 1 comes, that changed to, that one is change to 0. Then a 0 come, that is changed to 1. So the answer is 0.1001. That is written over here, 0.1001 to the base 2. Then another question, find the ones complement of 101100. Same logic. First, the least significant bit is 0 and its complement is 0 is replaced with the 1. Next comes 0, that is replaced with the 1. Next comes 1, so that is replaced with the 0. Next comes 1, that is replaced with the 0. Then comes a 0, so we have to write 1. Then comes 1, so we have to write 0. So the answer is 010011 to the base 2. You can use this method to find out the ones complement. The trick is that we have to replace ones with zeros and zeros with the ones. Then in the coming slide, we will summarize the techniques we have learned so far, that is both r's complement and r minus 1's complement. Consider the binary number 10110100 to the base 2 and we need to find out its ones complement. There are two methods to find out the ones complement of a binary number. First method is using the equation r raised to n minus r raised to minus m minus capital N that we have done, and it will take some time. And the second method is what we can simply replace ones with zeros and zeros with the ones. So the ones complement of this number is 1 1 0, then 1 0 0 1 0. That is written over here. That is 0 1 0 0 1 0 1 1. This 0 is replaced to 1. This 0 to 1. Then this 1 is replaced with the 0. This 0 is replaced with the 1. Then 1 is replaced with the 0. This 1 is replaced with the 0. Then this 0 is replaced with the 1. This 1 is replaced with the 0. So the answer is 0 1 0 0 1 0 1 1 to the base 2. Then we will summarize the rules for finding the 2's complement. Consider the binary number. There are three methods for finding 2's complement. So consider the binary number 10110100 to the base 2. The first equation method is using the equation. The equation for 2's complement is r raised to n minus n, or this is the equation for r's complement. Here r is 2. So 2's complement r raised to n minus n. That we have seen many examples and I think it's clear to you. Next method is the shortcut method that we have discussed during the r's complement lecture. That is, leaves all the least significant zeros and the first one unchanged. That is, we have to change these three bits unchanged. So the answer will become 0 0 1. First three bits, first non-zero bit and the trailing zeros are left as unchanged. Then we have to replace ones by zeros and zeros by ones. So 0 comes, 0 is replaced with the 1, 1 is replaced with the 0, then again a 1 comes, that is replaced with the 0, then 0 comes, that is replaced with the 1, 1 is replaced with the 0. Therefore the answer is 0 1 0 0 1 1 0 to the base 2. This is the another method, second method for finding the 2's complement in the case of binary number system. But we are commonly going to use a third method, that is, first we need to find out the ones complement of the given number. Then we need to add a 1 to its binary 1 to it to form its equivalent binary number. Consider in the question, first find, okay, question is same, we need to find out the 2's complement of 10110100. That is 10110100. So what we can do? First, we have to find its ones complement. Finding the ones complement is very easy. Using the shortcut method, we can do it in the following way. That is, we have to replace all zeros with ones and ones with zeros. So these two zeros become ones. This 1 will become 0. This 0 will become 1. These ones, two ones will become two zeros here. 1, 1. This 1 will become 0. This 0 will become 1. This 1 will become 0. So this is the equivalent ones complement of the given number in the question. This number is equivalent ones complement is this number. Next, to find the two's complement, first find the ones complement, then add 1 to the ones complement. So we need to add a 1 to this 1 complement. That is 0, 1, 0, 0, 1, 0, 1, 1. From this previous step, we are getting this ones complement and we need to add a 1 to it. So using the binary addition, 1, 1, 0 with a carry 1, 1, 1, 0 with a carry 1. That 1 is copied to here, 1, 0, 0, 1, 0. So this is the two's complement of the given number. Thank you.